Hey, welcome back. In video 2, I'm going to show you how you can identify how many significant figures there are in any given number. Coming up. So, Jason went to a field trip to his local football stadium. He had to measure the length and width of the football pitch using a meter wheel, like the one shown here. He measured the length and width as 100 meters and 60 meters respectively to the nearest meter. So the length of the pitch is 100 meters and the width of the pitch is 60 meters to the nearest meter. The fact that the question says to the nearest meter, it means that they've measured it to the nearest unit. The length is 100 meters. So if we think about the hundreds, the tens and the units, they've measured it to the nearest meter, so to the nearest unit. That means that this data value or this measurement is correct to 3 significant figures. And if we take the width at 60 meters, remember they've measured it to the nearest meter, so this measurement is correct to 2 significant figures. This digit could have been 1, 2, 3, 4, 5, 6, 7, 8 or 9. It just happens to be the case that it's 0, 60 meters. So significant figures indicate the degree of accuracy of a measurement or data value. The fact that the length has been measured to the nearest meter indicates that even though it's 100 and these are zeros, it could have been 101. But we know that Jason has measured it all the way to the nearest meter, hence 3 significant figures. Now moving on, consider the following examples. Let's call this rule number 1. We've got 2,000 meters, $32,000, 3,550 kilometers per hour. Trailing zeros are ambiguous and do not count as significant figures unless indicated by including a decimal in the number. Pause the video here, write in the comment section below and see if you can find out how many significant figures each of these numbers represent. Okay, so for the first question, 2,000 meters, only the 2 counts. So we have 1 significant figure. Remember, the trailing zeros are ambiguous. We don't know how accurate this measurement is. Following this same principle that trailing zeros are ambiguous, $32,000, only the 3 and the 2 are significant. We only have 2 significant figures. The third question, again, the 0 is ambiguous. We know that we've got 3 significant figures, but we don't know whether this has been measured to the nearest unit. So let's say we had 32,000 with a decimal at the end of it. We know the bank clerk has measured this all the way down to the nearest dollar. It just happens to be the case that there's exactly $32,000 in this bank account. I mean, it could have been 32,456. But this value, because it has a decimal, has still been checked to the nearest dollar. In this case, we have 5 significant figures. So rule number 1, trailing zeros are not significant unless indicated by including a decimal in the number. Okay, consider the following examples. We'll call this rule number 2. So we have 50,013 meters, 1.008 kilometers, $704. Pause the video here and see if you can figure out how many significant figures there are in each number. So rule number 2, zeros in between or in the middle of numbers are all significant figures. So in our first example, we have a total of 5 significant figures. In the second example, because we have these 2 zeros in between, they're significant. So we have a total of 4 significant figures. For the last question, the 0 between the 7 and the 4 is significant. So here we have 3 significant figures. So rule number 2, to recap, all zeros in between numbers are significant. Right, moving on. Consider the following under rule number 3. We have 0.02 liters, 0.30 meters, and 0.00970 megabytes. Don't ask me where the megabytes came from. So again, pause the video here and write in the comment section below what you think the answer is to each of these questions. So rule number 3, leading zeros do not count as significant figures. So let's see if you got these questions right. 0.02 liters, only the 2 is significant, so we have one significant figure. The second question, 0.30, we have 2 significant figures. Remember, because we have a decimal, this trailing 0 counts. So the leading zeros do not count, so 0.00790 has 3 significant figures. You may be looking at this 0 and this 0 and thinking, well, why do these count? Go back to rule number 1 and you'd find that if you have a decimal, then all trailing zeros count. So to recap, rule number 3, leading zeros do not count, are not significant. Okay, so let's recap. Rule number 1, trailing zeros are not significant unless there is a decimal in the number. An example would be 32,000 is only 2 significant figures, whereas 32,000 with a decimal at the end has all 5 significant figures. Rule number 2, all zeros in between are significant. So for example, 1.008 kilometers is equal to 4 significant figures because the zeros in between count. And rule number 3, leading zeros are not significant. So 0.02 liters only has 1 significant figure. The leading zeros do not count. So remember, significant figures indicate the degree of accuracy of a measurement or a data value. Follow these 3 simple rules to make significant figures made easy. Once again, thank you for watching. If you found this video helpful, drop me a like and subscribe. Make sure to watch parts 1 and 3 where I show you how to add and subtract significant figures. See you in the next one.